Hey guys, welcome to Algo Forces. So today we'll be going ahead with Leetcode problem number 2559, that is count vowel strings in the ranges. So here you'll be given two arrays, one of words and one of queries, and it what it asks is for each query I equals to LR, we have to find the number of strings present in the range Li to Ri, both inclusive of words that start and end with the vowel. So let's say you are given queries and it is 0 and 2. So basically what you have to do is you have to find all the strings from the range 0 to 2 which start and end with the vowel. So in this case it is 2 because it is BA and ECE. Okay, so and similarly for this one from 1 to 4, so basically it is this, that is BCB, ECE, AA. Sorry, no, BCB is not there. So basically you have to consider ECE, AA and EE. So it is 3. And similarly from 1 to 1, okay, so it is 0 because BCB is not the valid string. So basically that is what you have to do in this question. And now let's move ahead with the approach. Okay, so what will be the brute force way to solve this question? So it will be like I'll iterate through the queries array, and then for each of the element, I will find all the strings between 0 and 2. Okay, so basically if it is 0 2, so I'll start from 0. I'll just go to go to 2 and I'll just count all the strings possible. But here, but here the query start length can be maximum of 10 raised to 5. So there can be even 10 raised to 5 possible uh, 10 raised to 5 possible queries, and there can be 10 raised to 5 possible words. Okay. So overall n raised to k complexity will give we might go up to 10 raised to 10, which is a very large number, right? And it will give you TLE. So how do you optimize this solution? Okay, so can we have some approach which gets completed in maybe order of n time? Okay, so here you are given some ranges, right? And you have to consider the ranges. So can I do something maybe of sort of prefix sum? Can I maintain some prefix sum? And maybe if I can do that prefix, I'll just take queries of one. I have some maybe prefix sum array. I don't know how I will get it. We can think of it later. So I will do queries of one. Okay, minus queries of 0. So basically, okay, so minus I will do queries of 0. Okay, so let's say how I'll do is, let's say if I have to consider the range 0 to 2. So here queries of 0, that is 0, and okay, I have to do queries of 0 minus 1. Okay, so here queries of 0 minus 1 becomes less than 0. So basically we won't do the minus here. But if let's say if it is 1 to 4, so what I'll do is queries of 1 is 4, 4 minus queries of 0, that is 1 minus 1. So I'll do 4 minus 0. Okay, so prefix sum of 4 minus prefix sum of 0. So prefix sum of 4 minus prefix sum of 0. Okay, so what this will give me is, so basically it will give me the count of all the strings having vowels between 4 and 0, that is between 1 to 4, and that is what we wanted, right? So yes, this can be one of our approach. And now how should we calculate the prefix sum? So basically I will start with 0. Here this is a valid string, right? So I'll just add 1. Now again I will go to 1. It is not a valid string, so I will do the previous count plus only previous count, because I cannot add 1 here as this is not a valid string. Now comes EE. So again I'll do previous count, that is 1 plus 1, that is 2. Okay. Now again comes AA, so I will do 2 plus 1, that is 3. And again comes E, this is also valid, so 3 plus 1 is 4. Okay. And now let's just dry run the solution once for 0 and 2. For 0 and 2, so basically it is 2 minus here. Okay, so it is 2 minus, see, 0 minus 1 is minus 1, right? So we won't just remove anything from this 2, so it will be 2 itself. Okay. Now comes 1 to 4. So basically count of 4 is 3. Sorry, count of 4 is 4. So 4 minus count of 1 minus 1, that is 0, that is count of 0 is 1. So this is 3. So this is 3. And now comes 1 to 1. So count at 1 is 1 minus count of 1 minus 1, that is count of 0 is 1. So this will give 0. And this is correct, right? Because from 1 to 1 there is only BCB, right? So there is no string having starting with vowel and ending with vowel. Okay. So that is how we'll proceed with the approach. And now we'll just proceed with the coding part. And before that, what will be the time complexity of this solution? So it will be order of k, where k is the length of the queries array, and the space complexity will be order of n, where n is the word's length. Okay. So we can now proceed with the coding part. Okay, so what all do we need here? We'll just need one count array, and it will be words dot length. Okay, now I will just initialize count of 0 equals to, let's say there is this method valid which checks whether the string is valid or not, and it will return me boolean. So if it is valid, then I'll just make it 1, or I will make it 0. Okay, and it will be words of 0. Now I'll just loop through the words dot length I plus plus. So basically it should start from 1 because we have already counted 0. Now count of I equals to count of I minus 1. Now if valid words of I, if it is valid, then I will just increment the count. Okay. And that's how we'll generate our prefix sum. Now I will just loop through the queries in I'll just loop through the queries. I equals to 0, I less than queries dot length I plus plus. Okay, and I also need one more array, that is output equals to new integer queries dot length. Okay, and output of I will be queries of I and z and 1, and if queries of I 0 minus 1, if it is greater than or equal to 0, then we will do output of I minus equals to queries I 0 minus 1. So if queries of I 0 minus 1, if it is less than 0, right, so we will not be subtracting anything from it. Okay, and now comes the final. tab, we will just return output array, and we have to complete the method as well, valid, and this will have string word, and just what we'll do is we'll just have one count variable, and we will have the vowels array. So this will be character. Okay, actually it should have all the vowels, that is A, then comes C, then comes I, then comes O, and then comes U. Okay, and here we are given that words of I consists only of lowercase English letters, so we do not have to consider the uppercase ones. Now I'll just loop through the vowels. In vowels, if word dot character at 0 equal to vowel, that is the first character is equal to vowel, then I will do count plus plus, and if last character is equal to vowel, then again we will do count plus plus, and we'll have the condition if count equals to 2, which means both the first character and the last character is equal to vowel, and then we'll just return true, otherwise we will return false. It means that not both first and the last characters are equal to vowel, either it might happen that only first character is equal to vowel and the last is a consonant, and the vice versa. Okay, so this seems fine, and okay, now let's try to run the solution. Okay, yeah, this should be like this, and even here it should be like this. Okay, sorry, we had made a mistake here. So I'm not using count array. I don't know why. So there it should be count of queries of 1, and here also it should be count of queries of I0 minus 1. Okay, it worked. Now let's try to submit it. Okay, see, so it got accepted. So this is the whole solution, and I hope it is clear to you. If you have any doubts, then please comment in the comment section, and I hope you like and subscribe this video. Okay, then bye bye.